So for the second half of this video set, we're going to do a review of logarithms. So similar to our unit circle review we did earlier, we're not going to go fully in depth on the logarithms. We'll kind of chunk it up over the course of the semester so that by the end of the semester we have a kind of more practice with doing trig and doing logarithms. All right, before we talk about logarithms, we have to talk about exponentials. All right, so what is an exponential? It's basically just when you have x in the exponent of your expression. So if the x is up there, that's an exponential, all right, exponential in the exponent. All right, just as a review, an exponential basically means you're multiplying a number by itself. So 2 cubed is 2 times 2 times 2, and that will give me 8. All right, 1/2 to the 4th just means you have 4 copies of 1/2, and that would be 1/16. A negative exponents just move things to the other side of a fraction bar. So we can always put something over 1, and this negative exponent just is going to move this to the bottom of the fraction bar. So it's going to be 1 over 3 cubed. All right, so if I move it to the bottom of the fraction bar, the exponent becomes positive, and that gives me 1 over 27. And then the other thing is that the 1/2 power is the same as a square root. A 1/3 power is the same as a cube root, and so on. So for this one, 16 to the 3/2, I could write that as 16 to the 1/2 cubed. You break it up into 2 different pieces. You break it up into the fraction part, the 1/2 part, and the whole number part, the 3. I have 16 to the 1/2. Again, this means the same thing as the square root of 16, which is 4, and 4 cubed is 64. So that's just a quick review of how some exponents work. All right, basic exponents, negative exponent, and fractional exponents. All right, but now we can talk about what a logarithm is. So a logarithm is the inverse of an exponential. It just does the exact opposite of an exponential. All right, so what's that mean? If I have this exponential expression, a raised to the b equals c, well, my base of my exponential is a, which means the base of my log is going to be the same thing. All right, but b was going into my exponential, and now it's the output for my log. C was the output for my exponential, and now it's the input for my log. So the way I think about it with inverses is I kind of just switch places. All right, the inputs and outputs flip. All right, but log is the inverse of an exponential. All right, so similar to what we did with exponentials. All right, let's do the same thing with logs, evaluating, just figuring out what these values are going to simplify to. So log base 2 of 64, that's going to be equal to some number. But based on that last slide, if this statement was true, then 2 raised to the a power has to be 64. All right, so we just need to figure out what exponent do we put on 2 to get 64. And it's 2, 4, 8, 16, 32, 64 is the 6th power of 2. All right, so all these questions are asking what exponent do I put on that base to get what's in parentheses. So we're going to do the same thing here. 2 raised to what exponent equals 1/8? Well, one thing, we're taking a whole number and it turns into a fraction. So if you remember from our exponent examples, that means our answer has to be negative, because that's the only way a whole number is going to turn into a fraction with an exponent. And then how does 2 turn into 8 with exponents? 3. Again, make sure you're thinking about exponents, not multiplication. 2 times 4 is 8, but 2 cubed is also 8. All right, we're with the exponent, not the multiplication. What exponent do I put on 16 to get 4? Well, 4 is a smaller number, so 16 squared is going to be like 256 or something like that. So that's not going to work. We need to go down to a smaller number. And 4 is the square root of 16. So just like we saw before, the 1/2 power, 16 to the 1/2, is the square root of 16, which is 4. All right, so that one is 1/2. And the last one, log base 3 of -9. We're asking 3 to what power equals -9. And if you do positive numbers, you're just going to get bigger and bigger numbers, 9, 27, 81. If you do fractions, you're going to get square root of 3, which is not negative. If you do negative numbers, you're going to get positive fractions. So basically, what I'm trying to say is this is not possible, so this does not exist. All right, it does not exist because you can't put a negative number into a log. because an exponential will never equal a negative number. So this is really important to remember with logs. You can't put in negatives. You also can't put in 0. All right, so just to recap, all right, domain is the things you're allowed to plug into a function. For exponentials, they're super nice. You just plug in any number into an exponential. But with logarithms, all right, you can only plug in positive numbers, and 0 is not positive, so you can't plug in negatives and you can't plug in 0, all right, but you can only plug in positive numbers into logarithms. And then just some notes about asymptotes. Exponentials graphs look like that. So you're going to have this horizontal asymptote on the left-hand side here where it kind of levels off. For a normal exponential, that'll happen at y equals 0. Logarithms, their graphs look like this. So they're going to have this vertical asymptote right there, and that happens normally at x equals 0 until we start changing the function around. All right, so a couple important things, how to evaluate logs. Remember, just thinking about what the exponent is to get you that thing in parentheses. And then you can't plug in negatives or 0 into a log. And then this stuff about asymptotes is also important. All right, so that's our kind of first review of logs. We'll do one more review of logs where we start looking at rules of logs and how to simplify expressions. I prefer right now just knowing how to evaluate logs is a good start. All right, so in class, all right, we're gonna start by taking derivatives and using the limit definition. All right, so let's do more practice of that we did last class. Then we're gonna take the graphs of some well-known functions and use those graphs to find out what their derivatives are going to be. And then if we have time left over, we're going to do some logarithm practice, because logarithms are going to come up on the AP exam a lot. All right, so once you'll be able to do all those things, you'll be able to slay the day.